So good morning everyone. So in today's classes we are going to see about the binary multiplier. So in the previous classes we saw about the adder. So we saw half adder, full adder, and then 4-bit binary adder, or it is also known as parallel adder, then carry look ahead adder, and then BCD adder. So actually these are some of the combinational circuits. So we are discussing about the combinational circuits. These are some of the combinational circuits, and that too we saw about the adders, different types of adders. So now we are going to see about the binary multiplier. So binary multiplier is similar to the decimal multiplier. So what step we have used to multiply decimal number, the same step we are going to use to multiply a binary multiplier. So first we will move on to the multiplying a 2-bit by a 2-bit. So that is you are going to multiply a 2-bit binary number by a 2-bit binary number. So you take the first bit as B1 B0 and multiplying by A1 A0. So B1 B0 is a 2-bit one number and A1 A0 is a 2-bit another number. So you are going to multiply these two numbers. So how will you multiply? The same procedure, that is, so first we are going to multiply A0 with B0 and B1. So you will get A0 into B0 and then B1 into A0. So first you are multiplying A0 with B1 and B0. So you get B0 into A0 and B1 into A0. So next you are going to multiply with the A1. So A1, how will you multiply?
A1
B0,
B0.
A1 B0 and then A1 B1. So the same procedure. So you are going to add now. So B0 into A0 will be directly obtained as a output C0, and B1 A0 should be added with B0 A1. You get C1, and if any carry means, say you will be obtaining here, and that too you will be add, you get C2, and if you have any carry, so that can be written as C3. So this will be your output. So B0 A0 you will not add with anything, you will directly B0 A0 directly get the output as C0 bit. Then B0 B1 A1 B0 A1 will be added, you will get a bit as C1, and if it is carry means it will go to the next carry next bit. So that carry and B1 A1 will be added, you will get C2 bit, and if you get any carry means that is written as C3. So your output will be C3 C2 C1 and C0. So for this only you are going to design a multiplier. So you are going to design a circuit. So in order to design a circuit, so first you have to multiply these two bits and then add. So you need a multiplier, that is you need to B naught, you have to perform A naught B naught, and that operation is known as AND operation. So you need AND gate and you need a adder. So here in this 2-bit by 2-bit adder, so you need, that is you are going to add only two number of 1 bit. So B1 A0 is 1 bit, B0 A1 is 1 bit. So you are going to add two numbers of 1 bit. Then what adder you have to use? What adder you can use? In order to add a 1 bit two numbers,
Half adder.
half adder, very good, half adder you can use. And similarly if you perform carry, that carry and another bit. So here also you need to perform only 1 bit 2 numbers addition. So here also you need only half adder. So first you need AND gate and half adder in order to design a multiplier. So we will go for the design. So first is you have to multiply A0 and B naught. So for that you need an AND gate. So B naught into A naught. So A naught B naught should not be added with anything. A naught B naught output of AND gate is just an output of C naught. So this output is known as the C naught. Then you have to obtain AND gate for A naught and B one. So another AND gate. So same A naught and then B1. Then you have to get A1 and B naught. So B naught, then A1. So these two output of AND gate should be given to a half adder. So half adder will get two input. So half adder two input kudutha, it will produce an output and one carry. So what is the name of the output? C1 is the output. So C1 and carry should be given to the half adder of next half adder to add these two bit. So you have to use another AND gate for A1 and B1. A1 and then B1. So it should be it should be given to a half adder. So carry of this first half adder should be given to the input of second half adder. So you get two input. So your output will be C3 and carry output will be C4. Is it sorry C2 and C3?
C2 and C3.
C2 and C3. C2 and C3. So is it clear? So this is the design of a multiplier 2-bit numbers. So multiplying a 2-bit by a 2-bit number will give you this design. So multiplication is normal multiplication. So normal multiplication, decimal multiplication, whatever step you do, that you do. So your first will be directly obtained from the AND output, that is C naught, and first AND output and second AND output you have to add these two. So you have to use half adder. You get the output as C1 and carry you add with the next half adder and you get B1 A1 AND gate that it should be fed to the second half adder. So you add these two, you will get the C2 and C3 output. So this is the design of an multiplier, that is you are going to multiply 2-bit by 2-bit multiplication. So this is a basic multiplication, that is basic bit multiplication. So is it clear about this design? How to multiply a 2-bit by 2-bit number, binary number. Is it clear, the design? Is it clear
Yes,
or
ma'am.
not?
Yes, ma'am.
Yeah. So next is you are going to multiply a 4-bit by a 3-bit binary number. So you are going to design a multiplier to multiply a 4-bit by a 3-bit binary number. So 4-bit means you take as B3, B2, B1 and B naught. So this is a first 4-bit number and you are going to multiply by a 3-bit number. So 3-bit number means you are going to multiply by A3, sorry, A2, A2, A1, then A naught. So this is a 3-bit number and this is a 4-bit number. So you are going to multiply this. So normal multiplication, that is you have to multiply first A naught with all the other B bits. So you write this as B naught A naught, B1 A naught, B2 A naught, and then B3 A naught. So for understanding purpose, I am dividing this. அதாவது ஒரு காலமும் செப்பரேட் பண்ணி வைக்கிறேன் ஏன்னா இங்க கன்ஃபியூஸ் ஆகக்கூடாதுங்கிறதுக்காக. So next you are going to multiply with A1. So you get B naught A1, B naught A2, sorry, B1 A1, then
B1,
B2
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 A1,
A1,
B3 A1.
B3 A1. So next you are going to multiply with the A2. So A2, you start here. B naught A2, B1 A2, B2 A2, then B3 A3. So directly B naught A naught, you are going to obtain it as C naught. Then you have to add these two. That output will be
C1.
C1. This output should be C2. This output should be C3. This output should be C4. This output should be C5, and if it is any carry, that should be C6. So you have to get C6, C5, C4, C3, C2, C1 and C0. So how will you multiply this? So in
AND
this
gate, ma'am.
AND gate, you will be using AND gate. Then what else adder you will be using?
One full adder or two off adder, ma'am.
So full actually for second column you need half adder, and for third column definitely you will be using 3 bit plus 1, but you don't have adder. You don't have any adder to add three numbers. So what you are going to do means, so you are going to add here row wise. So that is, so you are going to add the first row with the second row. Is it clear? So first row and second row you are going to add. So for that what you have to use? So first row la எத்தனை bit இருக்கு? So how many bits you are having in the first row wise you see? How many bits are there in the first row?
Four.
You leave the B naught and A naught. B naught and A naught should will be separate one.
3, ma'am.
3. So you can add 0 here. So it has 4 bit. Then in the second row, you have a 4 bit. So what adder you can use to
Full
add
adder,
a
ma'am.
4 bit for two numbers of 4 bit number? What adder you can use to add a two numbers of 4 bit number?
Full adder, ma'am.
Full adder, you should not say like that. You have to
Two.
say parallel adder or 4 bit adder. Is it clear? Full adder அப்படின்னா ஒரு பிட் தான் ஆட் பண்ண முடியும், கரெக்டா? So full adder can add a two numbers of, that is three numbers of one bit, இல்லையா? So இப்போ actually you are going to add, first row is 4 bit number and second row is 4 bit number. ரெண்டு 4 bit number ஆட் பண்றதுக்கு we have already seen a adder called parallel adder, or it is also called as 4-bit parallel adder. ஸோ அதாவது ஒரு நம்பர் 4-bit இருக்கும், இன்னொரு நம்பர் 4-bit இருக்கும். ரெண்டு 4-bit நம்பரையும் அதாவது 4-bit adder யூஸ் பண்ணி ஆட் பண்ணலாம். ஸோ 4-bit adderல ஆக்சுவலி என்ன இருக்கும்? வாட் வில் யூ ஹேவ் இன் 4-bit adder?
2 half adder.
2 half adder. 4 full adder you will be using. கரெக்டா? ஆடர்ஸ் ஞாபகம் வச்சுக்கோங்க. எல்லா கொஸ்டினுமே இம்பார்ட்டன்ட். இந்த கொஸ்டின் தான் கொஸ்டின் பேப்பர்ல இருக்குன்னு சொல்ல முடியாது. எல்லா ஆடருமே இம்பார்ட்டன்ட். மல்டிப்ளையர் இதுக்கப்புறம் வர எல்லா சர்க்கியூட்ஸுமே இம்பார்ட்டன்ட் தான். சரியா? ஸோ எந்த கொஸ்டின் வேணா உங்க கொஸ்டின் பேப்பர்ல இருக்கலாம். ஸோ அதனால டிசைனை நல்லா ஞாபகம் வச்சுக்கோங்க. ஸோ யூ வில் பி யூசிங் 4 ஃபுல் ஆடர் இல்லையா? 4 ஃபுல் ஆடர், ஒரு பிட்டுக்கும் ஒரு ஃபுல் ஆடர் யூஸ் பண்ணுமா இல்லையா? சரியா? Is it clear or not?
Yes, ma'am.
So 4-bit adder அப்படின்னா 4-bit 4 ஃபுல் ஆடர் யூஸ் பண்ணியிருந்தோம். அதுதான் ஆக்சுவலி இது. ஸோ இங்க நம்ம வந்து ஜென்ரலைஸ்டா 4-bit ஆடர்னு போட்டா மட்டும் போதும். யூ நீட் நாட் டிஸ்கிரைப் தி 4-bit ஆடர். ஏன்னா ஆல்ரெடி 4-bit ஆடர் நம்ம டிஸ்கிரைப் பண்ணியிருக்கோம். ஸோ எக்ஸாம்ல கூட 4-bit ஆடர்னு பிளாக்ல போட்டா போதும். யூ நோ நீட் டு explain about 4-bit adder. So in order to add the first row and second row, you are going to use a 4-bit adder in order to add the first row and second row. So So look at this diagram. So you see a 4-bit adder here. So in the 4-bit adder, inga irka 4-bit adder. So adula, so first row you're going to give us a first 4-bit number. So what is the first row? A0 into B0 is first AND gate. A0 into B0 is first AND gate, and the gate la irundhu vara output and directly you write it as a C0. So you take this. So first AND gate. So this is the first AND gate. So B0 into A0, that you straight away write it as a C0. So C0 ன்னு எழுதிருக்கீங்க. சரியா? அது adder குள்ள வரவே வராது. So the first AND gate output A0 into B0, you straight away write it as a C0. Then what else? What else in the first row? A0 into B1, that you are going to apply to an AND gate and give it to a adder. So for second AND gate, so you see the second AND gate. So A0 into B1. So third AND gate is A0 into B2, and the next is A0 into B3. So 2, 3, 4 AND gate. And what is the fourth bit? Fourth bit you don't have in the first row, that is 0. So here I am giving us 0 here. So this is the 4-bit first number. Augment ன்னு எழுதி இருக்கு இல்லையா? So your first number will be 0, then A0 into B3, A0 into B2, and A0 into B1. That is the first 4-bit number. Then addend ன்னு எழுதி இருக்கு பத்தியா, second 4-bit number. So that is the second row. That is A1 into B0, A1 into B1, A1 into B2, and A1 into B3. So that you are going as giving as a second 4-bit number. So A1 into B0, A1 into B1, A1 into B2, and A1 into B3. So this is the 4 AND gate for the second number. So for 4-bit adder, what will be the input? So one 4-bit number and other 4-bit number will be the input. So what will be the output now? So your output will be 4-bit number sum and then carry. So motto எத்தனை output வரும்னா you will be getting a 5 output from the 4-bit adder. அதாவது 4 பிட் வந்து சம்மும் ஒரு பிட் கேரியும் வரும். சரியா? So in that first will be taken as a C1. So இதுல வந்து first bit 4 பிட்ல first bit மட்டும் C1 எடுத்துக்கிட்டு மத்த பிட் எல்லாம் வந்து அடுத்த third row ஓட ஆட் பண்ண போறீங்க. So you are going to add with the third row. So first sum மட்டும் you will be considering as a C1. So first sum அந்த 4 bit adder ஓட அவுட்புட்டோட ஃபர்ஸ்ட் சம் யூ டேக் இட் as a C1 and rest of the bits இருக்கு பத்தியா, இந்த rest of the bit will be added with the third row. இந்த third row ஓட ஆட் பண்ண போறீங்க. Is it clear? So your first bit is taken as C1. அந்த ஆடர்ல இருந்து first bit C1 எடுத்துக்கிட்டு மத்த 3 bit வந்து மத்த 3 bit plus carry. So actually this is sum 1, this is 2, this is 3, this is 4. 4 bit sum ஒரு carry. So அதுல first bit வந்து you will be taking it as a output C1 and மத்த 3 பிட்டும் கேரியும் you are giving to the another 4 bit adder in order to add with the third row. இந்த third row ஓட ஆட் பண்றதுக்கு கொடுக்க போறீங்க. So your third row output will be given as a second input to the 4 bit adder. So your A2 into B0, A2 into B1, A2 into B2, A2 into B3 you will be giving as a second number for a 4 bit adder. So இது ஒரு 4 bit adder, இது ஒரு 4 bit adder. So you will be getting the output as a 4 bit plus carry. So அது என்னென்ன பிட்னா C2, C3, C4, C5 and carry will be C6. So you obtain this multiplied output C0, C1, C2, C3, C4, C5 and C6. So is it clear? So basic 2 bit by 2 bit தான் நீ ஆஃப் ஆர்டர்லயே கம்ப்ளீட் பண்ணிடலாம். ஏன்னா ஆஃப் ஆர்டர்ல வந்து ரெண்டு நம்பர்ஸ் ஆஃப் 1 பிட்டை நீ ஆட் பண்ணலாம். அதுக்கு மேல அங்க ஆபரேஷன் இல்ல. பட் யூ when you go for further bit multiplication you need more than full add. full adder கூட உனக்கு பத்தாது. ஏன்னா இப்ப இந்த செகண்ட் இதுல பாத்தீங்கன்னா 3 பிட் இருக்கு பிளஸ் ஒரு பிட் இருக்கு. சரியா? so full adder கூட உன்னால யூஸ் பண்ண முடியாது. so in order that so you have to use a 4 bit adder and that too you are going to add in row wise. so first row first 4 bit யூஸ் பண்ணிப்பீங்க, second row second 4 bit யூஸ் பண்ணுவீங்க. so first row second row you are going to give it as an input to a 4 bit adder and you get the output. so output and 4 bit adder output and 4 bit வரும் plus carry and that first bit is your straight away you take it as an output and அடுத்த 3 பிட்டையும் கேரியும் 4 பிட் சேர்ந்து அடுத்த ஆடருக்கு கொடுக்க போறீங்க. then third row will be the second number for the second adder. suppose if you have another row இன்னொரு row இருக்கு அப்படின்னா அந்த third rowல அந்த second 4 bit adderல வர அவுட்புட்டை வந்து first அவுட்புட்டை straight away ஒரு அவுட்புட்டா எடுத்துட்டு மத்த 4 பிட்டையும் fourth ரோவையும் இன்னொரு ஆடருக்குள்ள கொடுப்பீங்க. so it goes on like this. so அப்படி போயிட்டே இருந்தது அப்படின்னா so suppose for example if you have a k bit you are going to multiply k bit versus j bit means then you number of AND gate used will be k into j will be the number of AND gate and your j minus 1 number of k bit adder you are going to use. so this is the formula for a multiplier. so if you are going to multiply k bit by a j bit means so how many number of AND gates you will be using? K into j number of AND gates you will be using and how many number of adders you will be using? that is j minus 1 number of adders you will be using and how many bit adder? that is k bit adder you will be using. so in this case itself you take, so that is you have multiplied 4 bit number by a 3 bit number. so how many number of AND gates you will obtain? 4 into 3, so 12 AND gates you will be obtain. so you see count and see here. so you count and see here. so 1 2 3 4 5 6 7 8 then 9 10 11 12. so 4 into 3, so 12 number of AND gates you will be using here. so then next formula is how many number of adder you will be using? j minus 1, that is 3 minus 1, that is you will be using 2 number of how many bit adder you will be using? K bit adder. So two numbers of 4-bit adder you will be using. So you will be using two 4-bit adder. So this is the formula. So for generally, if they ask any number of bit, that is, they asked you 4 cross 4 also means, then you should not say they have not taught this, or this is not available in the book. So you have to design. So same procedure only. So you have to add row wise. So row wise, so means, so you will be 4 into 4, you will be using 16 AND gates, and then you will be using 3 numbers of 4 minus 1, 3 numbers of 4-bit adder. So first row and second row you have to add for that one adder, then output of that and third row you have to use for that second adder, and output of that and for next row you will be using, and that is the third adder. So how many bit adder you will be using? So you will be using, so inga எத்தனை bit இருக்கோ that much bit adder you will be using. Suppose if you have here 5 means you will be using 5 bit adder. 5 bit adderங்கிறது உன்னை படிக்கவே இல்லையா நினைக்காத. 5 bit adderங்கிறது என்ன, 5 full adder யூஸ் பண்ணினா அதான் 5 bit adder. So அப்ப என்ன வரும், 5 bit adder அவுட்புட் என்ன வரும், you will be getting 5 bit as sum and 1 bit as carry. So எத்தனை பிட் கொடுக்குறியோ அத்தனை பிட் அவுட்புட் வரும், ஒன்னு எக்ஸ்ட்ராவா கேரி வரும். So that is the design of multiplier. So is it clear?
Yes, ma'am.
So all of you clear with the multiplier? So any multiplier they are asking means you have to use this only. Is it clear? Is it clear? எந்த multiplier கொடுத்தாலும் இனிமேல் டிசைன் பண்ணுவீங்களா?
Yes, ma'am.
Okay. So next is the next topic is the parity generator and parity checker. So next we are going to design a parity generator and parity checker. So before designing this, we need to know what is meant by parity. So parity means, that is, so for example, you are transmitting this bit to a long distance. So you are transmitting 10101 to a longer distance for any communication. So for longer transmission, there may be some error, that is, there may be change in some bit, and you may get as a 11101 at the receiving end. So you need to check whether the received one is a correct one or not. So correct bit receive பண்ணிருக்கீங்களா இல்லையாங்கிறது உங்களுக்கு தெரியணும். ஸோ நீங்க ஒன்று டிரான்ஸ்மிட் பண்றீங்க, ஆனா ரிசீவிங் எண்ட்ல ஏதாவது ஒரு பிட் சேஞ்ச் இருந்தது அப்படின்னா உங்களால டிடெக்ட் பண்ண முடியணும். சம் யூ ஹேவ் டு டிடெக்ட் தட் தேர் இஸ் சம் எரர் இன் யோர் டிரான்ஸ்மிஷன். ஸோ ஃபார் தட் யூ ஆர் கோயிங் டு ஆட் அன் எக்ஸ்ட்ரா பிட் வித் அன் ஒரிஜினல் நம்பர். ஸோ தட் எக்ஸ்ட்ரா பிட் இஸ் நோன் அஸ் தி parity bit. ஸோ ஒரு ஒரிஜினல் நம்பரை டிரான்ஸ்மிட் பண்ணும் போதே எக்ஸ்ட்ராவா ஒரு பிட் வந்து நீங்க ஆட் பண்ணி அனுப்ப போறீங்க. ஸோ தட் எக்ஸ்ட்ரா பிட் இஸ் நோன் அஸ் தி parity bit. ஸோ why you are sending extra bit means, that is, you are going to add an extra bit here in order to make it as an even number, even parity or odd parity. So you have two numbers of parity. Either you can follow an even parity or you can follow a odd parity. So even parity means, that is, you are maintaining even number of ones mean, then that is known as even parity. Odd parity means you are maintaining odd number of ones means, then that is known as odd parity. Either you can follow even parity or you can follow odd parity. So if you are maintaining even parity, that is you are going to use even parity means, so that is you are going to send a number 10101. So this is the number to be transmitted, and you have to add an extra parity bit. So if you are using even parity means you have to make the number of 1 as even. So inga actually pathina how many number of ones here? 3 1 is available in your original number. So 3 is known as odd number, but you are maintaining even parity. So your parity bit should be 1. So your extra bit should be 1 for transmission. So you have to add an extra bit to an original number and you have to transmit, and that extra bit can be a 0 or 1. So எப்போ 1 இருக்கும் அப்படின்னா உன்னோட ஒரிஜினல் நம்பர்ல odd number of 1 இருக்கு, but you are maintaining even parity means you have to make that 1 as uh, 1. So suppose if you have a number 10101, so this is the number to be transmitted and you are maintaining even parity means then already even number of ones is available in your original number, so your extra bit added should be 0. So this is the extra bit added and this should be transmitted along with this. So parity bit means, so parity bit is an additional bit added to the original number so that it may make your number as even parity or odd parity. So if you are maintaining even parity தான் மெயின்டைன் பண்ண போறீங்க அப்படின்னா உன்னுடைய நம்பர் வந்து parity bit ஆட் பண்ணதோட சேர்த்து ஈவன் நம்பரா இருக்கணும். So additional bit can be 1 or 0 depending upon your number. So உன்னோட நம்பர் ஆல்ரெடி ஈவன்ல தான் இருக்கு அப்படின்னா you need to add 0. உன்னுடைய நம்பர் ஆட் நம்பர்ஸ்ல ஆட் நம்பர் ஆஃப் ஒன்ஸ் தான் இருக்கு உன்னுடைய ஒரிஜினல் நம்பர்லனா you have to add 1 in order to make it as even. So this is actually even parity. This is for even parity. Suppose if you have the same number 10101, so same number you are going to maintaining odd parity. Odd parity நீ மெயின்டைன் பண்ண போற அப்படின்னா you need to make the number as odd one. So already you have a odd number of 1, so your parity bit extra bit added should be 0. So this is the additional bit you have to add to the original number in order for transmission. So if you have 11101, so you have a even number of ones, but you have to maintain a odd parity. Then you have to add 1 as an extra bit and then transmit. So either you can use odd parity or you can use even parity. If you are using odd parity means the number of ones including the additional bit should be odd, and if you are maintaining even parity means number of ones should be even including the additional bit. So அதுக்கு ஏத்த மாதிரி உன்னோட additional bit 0வோ இல்ல 1ஓ இருக்க போகுது. So this additional bit is known as the parity bit. So இது எதுக்காக நம்ம போடுறோம் அப்படின்னா ரிசீவிங் எண்ட்ல சப்போஸ் இப்போ 010101 இருக்கு, சப்போஸ் இப்போ வந்து உன்னோட பிட் டிரான்ஸ்மிஷன்ல எரர் ஆயிருக்கு அப்படின்னா, ஸோ இப்போ நம்ம வந்து ஆக்சுவலி ஆட் பேரிட்டி மெயின்டைன் பண்ணியிருக்கோம், பட் ஆனால் ரிசீவ் ஆன இடத்துல என்ன ஈவன் பேரிட்டியா உனக்கு ரிசீவ் ஆயிருக்கு. ஸோ அப்பனா உனக்கு என்ன தெரிஞ்சுக்கலாம்? ஸோ டெஃபினெட்லி தேர் இஸ் அன் எரர் இன் தி டிரான்ஸ்மிஷன். ஸோ பேரிட்டி பிட்னால யூ கேன் eliminate only, that is you can identify only one bit change. ஸோ ஒரு பிட் சேஞ்ச் ஆயிருந்தா மட்டும்தான் உன்னால ஐடென்டிஃபை பண்ண முடியும். சப்போஸ் ஃபார் எக்ஸாம்பிள் 2 பிட் சேஞ்ச் ஆயிருக்குன்னு வச்சுக்கோ. ஸோ 2 பிட் சேஞ்ச் ஆயிருக்குன்னா ஆல்ரெடி 2 காம்பன்சேட் ஆயிடும். ஸோ அதனால இதுவும் ஆட் தான் இருக்கும், இதுவும் ஆட் தான் இருக்கும். யூ கேனாட் ஐடென்டிஃபை தி எரர் இன் யோர் டிரான்ஸ்மிஷன். ஸோ பேரிட்டி பிட் கேன் ஐடென்டிஃபை ஒன்லி சிங்கிள் பிட் எரர். ஸோ ஒரு பிட் எரர் சேஞ்ச் இருந்தாதான் நம்மளால வந்து ஐடென்டிஃபை பண்ண முடியும். ஏன்னா because you are maintaining either odd parity or even parity. So odd parity maintain பண்ணிருக்க single bit change இருந்ததுன்னா அது கண்டிப்பா even parity ரிசீவ் ஆகும்போது உனக்கு கிடைக்கும். ஸோ அப்பயே நீ டிசைட் பண்ணிடலாம், that is there is some single bit transmission error in your transmitted bit. Is it clear what is meant by parity bit and what is the purpose of adding parity bit? Is it clear?
Yes, ma'am.
Hello, are you hearing?
Yes, ma'am.
Yes, ma'am.
புரியுதா இல்லையான்னு கொஞ்சம் சொன்னாதாம்மா. ஏன்னா நம்ம வந்து பாத்துக்கிறது இல்ல. சோ அதனால திடீர்னு எனக்கு நெட்வொர்க் கனெக்டிவிட்டி இருக்கா இல்லையானே டவுட் வந்துருச்சு. Is it clear or not? What is the purpose of parity bit and what is meant by parity bit? Is it clear?
Yes, ma'am.
So next, so you are going to generate the parity bit now. So the circuit which generates the parity bit is known as parity generator, and circuit which check the parity bit, that is check at the receiving end, is known as the parity checker. So you're going to design both parity generator as well as the parity checker. So you are going to design a 3-bit parity generator. So 3-bit parity generator means, so you need 3-bit number input, that is XYZ is the 3-bit number. So 3-bit means input will be combination of 8 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So this is the input XYZ. So since you are going to design 3-bit parity generator, you are going to use input as 3-bit 0 0 0. So for this number, you are going to generate a additional bit, parity bit, for even parity as well as for odd parity. So the circuit should design for even parity. That design is known as even parity generator, and the circuit which generates odd parity is known as odd parity generator. So இப்போ இதோட output என்னவா வரும் சொல்லுங்க. So actually you're going to first you're going to design even parity. So even parity அப்படின்னா actually zero number of 1 is considered as an even. So first you take the first 0 0 0. Already in the input you have even number, so no need to add an additional bit, that is a additional bit added will be 0 here. So because for even parity already it is even only, so 0 number of 1 is considered as even, so additional bit added will be 0. So 0 0 1, so you have odd number of 1 here, so you have to generate an additional bit in order to convert it to even number of 1. So you have to add 1 here. Is it clear? So you tell me, for 0 1 0, parity bit for even parity is
We should add one, ma'am.
1. So you have to add 1. And for 0 1 1, what bit you have to add?
Zero.
Zero, ma'am.
0. And for 1 0 0, what bit you have to add?
One.
One, ma'am.
1. And for 1 0 1, what is the bit you have to
Zero.
add?
Zero, ma'am.
0. For 1 1 0, you have to add
Zero.
0.
Zero,
And,
ma'am.
and for 1 1 1, you have to add
One, ma'am.
1. So this is the parity bit you are going to add. So actually XYZ is input and you have two output. So that is, you are going to design two logical circuit, one for even parity and another for odd parity. So for odd parity, actually 0 number of 1 is considered as even number. So for odd parity, you have to add 1 here. And for 0 0 1, what is the odd parity?
Zero, ma'am.
Zero, ma'am.
0. And for 0 1 0,
Zero, ma'am.
0. For 0 1 1,
One.
1.
One, ma'am.
1 0 0,
Zero.
0. 1 0 1,
One, ma'am.
1. 1 1 0,
One, ma'am.
1. Then 1 1 1 will be
Zero, ma'am.
0. So this is the truth table for a parity generator. So I'm going to design 3-bit parity generator. I'm going to design 3-bit parity generator. So your input will be XYZ. So you have, since you have 3-bit, you have 8 combination from 000 to 111. So you have to now write the output. So output is, you have to design even parity generator as well as odd parity generator. So for even parity generator, you have to add an additional bit 0 or 1 depending upon your bit transmitted. So even number of 1 already உன்னோட நம்பர்ல இருக்குன்னா you have to add 0. Even number இல்லாம odd number இருக்கு அப்படின்னா you have to add 1 for even parity. So that is the vice versa for odd parity. So this is the truth table to design a even parity generator and odd parity generator. So next you have to use a, so design பண்ணோம் அப்படினாலே truth table வந்துருச்சு. அடுத்து you have to use k-map in order to obtain boolean function for PE and P naught. So simplified boolean function kapram you need to design. So I think time is over, I think. So in the next class we will design the, so k-map போட்டு எடுத்துட்டு வாங்க இதுக்கு. So then we will design the even parity generator, odd parity generator, and then parity checker. So are you clear up to this? Is it clear or not?
Yes, ma'am.
So you use k-map to obtain the function parity, even parity generator and odd parity generator, and we will continue in the next class, the design.
Madam?
Yes, sir.
Yeah, madam, this is Pondicherry from CSC. I want to
Yes,
talk
sir.
one announcement from our students.
Okay,
Madam,
sir.
off the record.
Aruna ma'am.
Yes, ma'am. Can you hear me? Yes, ma'am.
Ma'am, off பண்ணிடுங்க ma'am record.
Okay, ma'am. Okay, ma'am.